Hello friends, today is my fourth video regarding Cisco packet tracer. Here I'm going to demonstrate how OSPF routing works to communicate the PC in different routers, or you can say PC in different networks. For here I have taken one topology here having three networks. First network is having network ID 192.168.1.0/26, and my second network is 192.168.1.64/26, and my third network having network ID of 192.168.1.128/26. All of them have 64 IP addresses. So first we will set the IP addresses for the concerned PC. So for PC 0, IP is default gateway is 192.168.1.1, and the IP address is 192.168.1.2. subnet mask is 255.192. For my second network, PC1, default gateways 192.168.1.65, IP address 192.168.1.66, and signal marks 192. My third PC number 2, having default gateway as 192.168.1.129, IP address is 192.168.1.130, subnet marks as 192. Now I have set the IP addresses for the concerned PC. After setting the IP address, now we have to configure the interface for each network which is connected to their particular router. So for the first network, let's move to PC3 to configure this port connecting to the network number 1. This interface is dig 0/0/0. IP address is 192.168.1.255.255.255.192. The IP address for this interface will be the gateway IP address of the first network. Then no shutdown, that's it. So after configuring this interface, let's move to the next network for this interface. So let's move to PC number 4. Gig 0/0/0 the address 192.168.1.65.192 no shutdown exit. Then similarly for the third network, let's move to PC number 5. PC number 5. Enable config T press gig 0/0/0 IP address 192.168.1.1.255.255.255.192 no shutdown exit. Now we have configured all the interfaces. Now like in my third video where I use the remote login privilege to log into the router from a remote PC, so similarly we will apply the technique to make this thing more realistic. So let's look for the first network to go to PC3. Enable a secret password. Let's say cisco username admin password admin and line virtual type, and then login local transport input telnet. Now since we have enabled the remote login, we can remove this PC3. So similarly for the second network, go to PC4. Enable secret password cisco username admin password admin line virtual type login local input telnet. Here we have also enabled the remote login. Now we can remove this PC4. network. Let's go to PC number 2. Let's go to PC number 5. Secret. Cisco journal admin password admin picture type 04 login local transport input telnet JIT. So now we can remove this PC 5 also. So let's try to remote login from PC 0 to the first router. PC 0. Telnet 192.168.1.1 admin enable cisco 50. Now we have entered into the router global configuration mode. Here the serial port connected to this router are SC010 and the SC011. First C010 IP address 10.0.1.255.255.255.252. This is a subnet mask giving 4 IP address, and now shut down. Similarly, next interface SC011 IP address 10.0.0.5 subnet mask 255.255.255.252, and now shut down. Now we have configured for this serial port. Let's configure for the second router serial port having interface SC010 and SC011. So let's move to PC number 1. .168.1.65 admin enable cisco 150 and SC0/1/0 IP address 10.0.6 255.255.255.252, and now shut down. Next interface SC0/1/1 IP address 10.0.0.9 5.255.252 is the subnet mask, and now shut down. Exit. So for this interface we have also configured. So for the third network having interface as SC010 and SC011. So let's move to PC number 2. Terminate 192.168.1.129 min enable cisco 150 0/1/0 IP address s 10.0.0.2 255.255.255.252. No shutdown. That's it. I think SC 0/1/1 IP address 10.0.0.10 255.255.255.252 and no shutdown. Okay. Now we have configured all the serial interfaces. Now till now I haven't configured the OSPF routing protocol till now, so when I try to ping from PC0 to PC1 or PC2 it won't work, but still let's check. Let's go to PC0 first. Exit from the router mode. So ping is ping the second network PC 192.168.1.66. It says destination host unreachable. Similarly for 130 it says destination host unreachable because till now I haven't configured the OSPF routing protocol. So let's again log into the router first to configure the OSPF 2.168.8.1.1 admin enable cisco 150. So router OSPF, here I have to put one process ID, let's say 1, and this process ID is unique, or it's a unique identifier for only for this particular router, because in one router there may be multiple process ID. So to identify which process ID we are giving S1, then I have to mention my network. My first network is 192.168.1.0, and here I have to put the wildcard mask, which is just opposite of the subnet mask. Normally subnet mask was 255.255.192, so 255 means all 8 bits are 1. So just take the complementary of 1, which is 0. So we have 0.0.0, and the last is 192. It will have two number of 1 and the 6 number of zeros. So in this wildcard marks, 1 will be changed to 0 and 0 will be 1. So we will have 2 number of 0 and the 6 number of 1. So otherwise we can just do like this. Just subtract 192 from 255. 255 minus 192 give 63. This and the area. Here in OSPF, each network belongs to a particular area. Like say network 1 belongs to area number 1, network 2 belongs to area number 2, and likewise. but when we are going to communicate between the networks, there must be a common backbone. So for the backbone, we will give area as common area is area 0. So similarly, the next network I have is 10.0.0.0 is net marks is 255.255.252. So 255 will be changed to 0. So 3 times 0, 2, 3, and 252. Subtract from 255 will give 3. Area as 0. Similarly, my third network is 10.0.0.4, and the wildcard marks is same here. Now I have configured the OSPF for my first network. Let's configure the OSPF for the second network. Let's move to PC number 1. Router OSPF. Here there is no mandatory that the process ID shall be common for different this OSPF network. Like for example, I have given process ID 1 in my first OSPF network, so I can give process ID 1 or any number like 2 or 3 in my next this OSPF network, because this process ID is only identifier to the local network. So I say I give process ID as 2 and network 192.168.1.64. So 255.255.255.192, which wildcard marks will be 0.0.0.63. Maybe area 0. Network 19 network, next network is 10.0.0.4 and 0.0.0.3, area 0. And the next network is 10.0.0.8, wildcard marks will be same. Exit. Now I have configured for the second network also. So now for the third network, let's go to PC number 2. So router OSPF, let's say process ID is 3. Network 192.168.1.128. So wildcard marks will be 0.0.0.63 and the area ID is 0. Network 10.0.0.0 and subnet marks will be 0.0.0.3. area is 0 and another network is 10.0.0.8. Good. Now here see our show IP OSPF neighbor. Let's see our neighbor. So for the this what from our topology, we just have we are looking the OSPF configuration for this network. So its adjacent neighbor will be 10.0.0.1 and the 0.9. So let's again check here. Let's say that it is 0.1 and 0.9. okay, and this is the router ID. It says that 1.1 and 1.65. let's see again here. And 1.65. okay, what happened, this router ID, whenever the adjacent of this interface is 0.1 and 0.9, and for this 0.1, this router ID, this router will take a router ID, but we haven't defined any router ID. So what will it take? It will take the maximum having the greatest IP address as its router ID. So it has 3 IP addresses: 0.1, 0.5, and another is 192.168.1.1. so 192 series is the biggest one, so it will by default will take as the router ID. So similarly for this also, one in the one IP address is 0.9, 0.6, and another is 192 series 1.65. so by default 1.65 will be taken as a router ID. So again, let's check router number 2 again, PC number 2. See here, 1.1 and 1.65 is a router ID. So let's ping our network from the router, ping 192.168.1.2. it's pinging now, and another is 66. it's pinging. We can also check the simulation for this. Let's see the simulation mode activated, and let's see from the PC 0. PC 0, I will exit from PC 0 first. Wait. In simulation mode, PC 0, ping 192.168.1.66. So let's see how our network behave. the traffic is flowing. Here a router will automatically run an algorithm and it will determine the shortest path to reach the destination network, making adjacencies or neighbors. So from our destination PC, an acknowledgement message is sending back to the source. This is basically a reply of the hello message sending from the source while initiating the communication, and the successfully reach. So this is demonstration of how OSPF work to communicate between different networks. So thank you.